Hello everyone, this is sample problem 3a on page 55. Alright, that's the page 55 right there. This is sample problem 3a. Now the problem says a hunter purchases a gold crown like the one shown in this figure at a market. After she gets home, she hangs the crown from the scale and finds its weight to be 7.84 newtons. So that's the weight that the hunter found as she is finding the weight of the crown. So the weight of the crown is 7.84 newton. That's the real weight of the crown. This is the real weight of the crown, which we call it Fg. The real weight, we call it Fg, which is equal to the weight of the crown. And this is 7.84 newton. She then weights the crown while it's immersed in water. Now that the crown is immersed in water, the weight that we will get will be, the scale will read 6.86 newton. Now this is the apparent weight because the crown now has been weighed inside water. All right, so if you weigh something inside water, this will be the apparent weight, or we can call it F net. I'll just write down F net here. F net and apparent weight, they mean the same thing. All right, and of course, and then the question goes like this. This is the unknown. It says, is the crown made of pure gold? Explain. So we will try to find out if this crown is actually real gold or not. How do we find that? Well, you simply find the density of the crown. Once you know the density of the crown, you can go back to the table that we have in the book to see if this density will match with the gold's density. If they both match, that means this is a real gold. If it does not match, that means this is a fake crown. So this is how we will do it. We've got two givens, Fg, F net, and then we have the density of the water. The density of our fluid is the density of the water, which is known to be 1000 kilogram cubic meter. All right, so these are all the givens that we have. We've got three given now and one unknown. Let's find out. Let's see how to solve this problem. All right, so it's pretty simple and straightforward. Let me just write down the known first for you, and then we will solve it. So I've got Fg equals to my Fg, which is my real weight. It is equal to 7.84 newton, and my apparent weight, which I call it F net, is equal to 6.86 newton. All right, so these are my given, plus I know the density of water, so I'll just write down rho F, which means the density of the fluid, F fluid. So the density of my water is 1000 kilogram cubic meter. This is my density. What do I want to find is the density of the object, rho O. This O means the object. What is the answer for the density of the object? Well, we'll have to find out. Now the equation for this case is this. This is a very useful equation. We will need it for so many questions. This is Fg divided by Fb, which is the buoyant force. Fg divided by Fb equal to rho naught, that means the rho of the object, divided by rho F, which is the density of the fluid. Okay, so here we've got Fg, this is the real weight, we've got it. We've got the density of the object. No, we don't have it. This is what we are trying to find, so I'll just put a question mark on top of it. We've got the density of the fluid, of course, but we have not got Fb. This is the only problem that we have in the question. We don't have Fb. And how do you find Fb? Well, that's pretty simple. You just find it using the using F net. This is the equation for F net. F net equals to simply Fb, right? It equals to Fb minus Fg. Why is that? Because Fb, the buoyant force, is an upward force. That means it's pushing up in that direction, while Fg is weight, which is pushing down, of course, right? So Fg, like gravitational force, this is always pushing down. So that's why it comes in negative sign. Okay, what is our F net? Let's put down the values. We've got F net, we've got Fg. This way we can find Fb and put it back into this equation here. So what is our F net? Our F net is 6.86 Newton equals to, what is my FB? I don't know. This is what I'm trying to find. FB, this is what I'm trying to find. What is my FG? Minus, so what is my FG? It is 7.84 Newton. Now, before we solve this and find FB, there's only one very important step, and that is Fnet is negative here. Why is that? Because the crown is immersed into the liquid, right? Into water. So that means the crown is sinking. In order to find the apparent weight, you have to sink your crown. So in this case, if you have your object sinking, that means the Fnet is negative. That means, which means that the gravitational force or the weight is winning, and the weight is negative, so your Fnet will also be negative. All right, so that's it. Let's solve the question. So this is what we try to find, FB. What I will do, I'll simply take this part here to the other part. All right, I'll take this one and take it to the other part. And then my equation will be, my FB will be, this is a negative. When it goes to the other side, it will become a positive. So this will be, instead of minus 7.84, it will be 7.84, right? It will be 7.84 because it's minus. When I take it to the other side, it will be positive. The sign will flip. And this will stay as it is, nothing happens. Minus 6.86 equal to FB. So this is my FB. If you put this in the calculator, this is the number that you get, 0.98. 0.98, this is the value that you get. And of course, that's in Newton, because we just found FB. This is FB. FB is the buoyant force. And of course, force is in Newton. That's the unit for buoyant force. All right, now that we found FB, we can put this number back into our equation all the way there. I'll just put it back here in this equation. I just found it. Okay, so let me just, I'll just simply go to the other page here so that we can calculate the final answer. So this is the equation that I had, Fg divided by Fb equal to the density of the object divided by the density of the fluid. So my Fg was, let me insert the number, but before I insert the number, I've got Fg, I've got Fb, I've got the density of the fluid. This is the only thing that I don't have, and this is what I'm trying to find. So good, I can find this now. And how do I change this equation to equation of the density of the object? Now this is clearly density of the object over density of the fluid. This is not what I want. I don't want a division. I want to find the density of the object. So how will I do that? Well, I'll simply take this side and take it up all the way to the other side. It's a division here. When it goes to the other side, it will become a multiplication. That means it will go to the numerator. First it's in the denominator, but when I take it to the other side, it will go to the numerator. So my equation will be the density of the object, rho naught. Okay, so the density of my object will be, this will not change, nothing changes from the left side, so I'll just write down Fg divided by Fb, nothing happened here. But this density of the fluid will go to the other side, and it will be rho f. Okay, so this is in the numerator, by the way. So you will just multiply the density of the fluid multiplied by the weight divided by the buoyant force. All right, so you will multiply those two together, because of course, as I said, it was in the denominator. You have to take it to the numerator. So let me multiply those two together. The density of the fluid multiplied by Fg. So the density of the fluid is known, which is water, 1,000 kilogram cubic meter. So the Fg is what? The Fg is 7.84 Newton. And I'll divide both of them, because once you multiply them, then you will go for the division. And the Fb, we just found it. Let me see what was the number. Yeah, it was 0.98. We just found it. It was 0.98. Now if I multiply all of those together, and if I just calculate them together, this is what I will get. I'll get 8,000 kilogram meter cubic. This is what I get, 8,000 kilogram meter cubic, because it's meter kilogram per meter cubic. That means the answer is correct. That means the unit is correct, because it's the unit for density, right? Density is kilogram cubic meter. All right, so this is this is pretty much all. This is the density of the object that we found. Now what we will do, we will go to the table in our book to see if this matches the density of the gold. If it matches the density of the gold, well, that's good, then we've got a real gold. If it does not match the density of the gold, then this will be a fake gold. And for the table, we will go back to page, let me see which page that is. Yeah, that's page 51. 51, we've got density for hydrogen, helium, steam, air, all the way down. At the bottom, we've got the density for gold, which is a lot. Density for gold is 19.3 thousand. 19.3 thousand. Now, this is clearly not the answer that we get. So this density, this is not too dense. This is light. This is not dense. This is very dense. So that is simply fake gold. I'll just write down fake gold. This is not a real crown. This is not a real gold. So this is how you solve problem sample 3A on page 55. I hope you guys understood the lesson. Try to solve that yourself. Once you solve it one time yourself, it will be simple. It's only 2 steps. First, you find FB. Second, you find the density of the object. And that's it. Just know the equation for FB and the equation for density of the object, and that would be it. Good luck.